Okay. Um, so today we're dealing with factoring, particularly factoring quadratics, but factoring other types of equations as well. We're going to be doing more factoring in the future. I am going to tell you this, and this is, I know I say this is important, that's important. Factoring is probably one of the most important single skills in algebra. Being able to factor an equation, to solve it, because usually the goal is solving the equation. Where are my zeros at? Where are my roots? That kind of stuff. We're going to concentrate on that. Factoring is the single best way to do it. It gives you the most information. It's the easiest way to solve them. And the factoring skills that you pick up here with quadratics are factoring skills that you use later for more complex equations. Okay, my calc kids, they're going to start doing applications coming up, and they're going to be doing a bunch of factoring. It's a big deal. It is the easiest way to do stuff. The skills you pick, the skills we're going to cover today are probably the most used for doing other things in math. And I don't think that's a stretch. I don't think that's a stretch. You've done all of this before. None of this is new material. But this is a very good review to get this down solid. The better you have today down, the easier so much stuff the rest of the year is going to be. Because we're going to be factoring for this, we're going to be factoring for that, we're going to be factoring off and on to solve equations throughout the rest of the year. Sometimes more heavily than others. But 2 or 3 other chapters that we're doing. Factoring is how you're going to do the work you're going to do. The last chapter we do, the last full chapter we do, I think it's chapter 10. Factoring is a major part of it. Absolute major part of it. If you don't have the stuff down that we're doing today, you are going to die when we get to that part. Okay, second semester is a lot harder. This is probably the biggest skill from first semester that will help you with second semester. And I don't really feel I'm overstating that. This is probably the single most important day, with the next day that we factor being the one right after that. Okay, and I'm not trying to stretch, I'm not trying to scare. This is a very realistic thing now. Okay, factoring rewriting expression is factors things that multiply to give you that. So numerically, you might have like 42. Well, oh, that's 6 times 7. That's factoring. What things multiply to give you that. Now, at 42, there's more than one pair that will give you 42. However, when you're doing algebraic factoring, there isn't an option. It's this and this. These are the only things that will multiply to give you that if you do it correctly and you break it down. Greatest common factor is one of the ones that my calc students probably actually use the most from here. You pull out a common factor, it makes things easier. You're going to want to learn that well. That is probably also one of the most, I think it's the easiest factoring to do, but it's the one that students tend to have the most difficult time remembering to do. Okay. Guess and check or Xbox. We're really not going to do a whole lot of guess and check. We're going to do a whole lot of that, though. Okay, a whole lot of that. I found it's the easiest way to do it. Guess and check, there are a couple of times where it's just fine. You can figure things out, shortcuts, but pretty much the Xbox is one of the easiest ways to do it. Factoring completely, sometimes you have to factor more than once to get your final answer. That's going to happen a lot the next day we do factoring. Difference of 2 squares. This is one, if you recognize the pattern, it's a piece of cake. If you don't recognize the pattern, you're never going to get it. And difference of 2 squares, if I have something squared minus something squared, 2 perfect squares, 1 square minus another square, that factors into the square root of the first plus the second square root of the first minus the second. Okay? If you get this down, if you learn this, this is one where if you recognize the pattern, it's a piece of cake. If you don't recognize the pattern, you're going to struggle with it. Okay? No ifs, ands, or buts. So, first one, factor each using greatest common factor or common factoring. When I do this, I look first at each part of it. First thing I do is look at the numbers. 18 and 3. What is the largest number that divides into 18 and 3? 3. 3 is the biggest number that divides into them. So 3 is my first common factor. I'm not doing anything else. I'm just, what's my first factor? Now I look at the variables. And I look, do I have the same variable in every term? I have a y in each term. What's the smallest power of y that I have? 1. I have y to the first. It's the smallest power is your common factor. So I can pull out a 3y. Now, this is not my answer. This is strictly what I'm pulling out of it. This is my common factor. The largest possible number that goes in everything, and then the largest possible variable that goes in everything. The variable's easy. You find a letter in each one and pick the smallest power. That's the easy one. Now I have to have what's left behind when I take those out. When I take 3 out of 18, I'm left with 6. 3 goes in 18 6 times, right? Factored out. I had y squared. I took out one of them. How many y's do I have left? 1. I have y to the first power. Now, many students would go, okay, now, ooh, I had 3y here and I pulled 3y out. I'm done. Which is wrong. If your common factor is one of the terms, you have to have a 1 left behind to mark its place. Because if you take 3y times 6y, you're going to get 18y squared, not 18y squared minus 3y. You have to have that minus 1. Very common mistake. If the factor is all of it, there has to be a 1 to mark its place if you took it out of it. Okay? Same idea, 16 and 24. What's the largest number that divides into both 16 and 24? What? I saw a 4, but the 4 is not the largest number. 8. 8 goes into both 16 and 4. So 8 is my numeric common factor. Now I have an a in each term. What's the smallest power of a? A to the first. So I have a. I have a b in each term. What's the smallest power I have of b? It's in each term. I have a b squared, and I have b squared in both. That's okay. But the 2 is my smallest exponent. That's what I pull out. Whatever the smallest exponent is, that's in every term for that letter. There's my common factor. Now I have to do what's left behind. Okay, 8, 16, I took 8 out, leaves me with 2. Took out a, took out b squared, I just have 2. 2 times 8ab squared is 16ab squared. That gives me my first term. I have a minus, so I have a minus. 8, I had 24, I took out 8. I'm left with 3. I had a squared, I took out one of them. That leaves me an a. Had b squared, took out b squared. I'm done. Okay. Nice and easy. Step by step. Don't try to do everything at once. Ooh, you're ahead of me. Okay, do those. Okay, most people are finished. So the first one, 8 and 2, largest factor is 2. M and m squared, I pull out an m. 8, pull out the 2, leaves me with 4. Took out the m, minus 2, I took out the 2. M squared, I took out 1m, so I have 4 minus m. Next one, numerically, I can pull out a 5. I can pull out an x squared, and I can pull out a y. So I took 5 and x squared out, and I just took out 1y, so I have 1y left in the first term. In the second one, I took out a 5, so that leaves me with 7. And then I took out x squared, and I took out y, so it's just 7. The last one, I have to look at all 3. 12, 6, and 4. 2 is the largest one for that. And then I have a c in every term, so I can take out 2c. Now, for 12, I took out 2, so I get 6. I took out 1 of the c, so I have c squared. Next one I had took out 6, took out 2, so it leaves me with 3. I also took out the c, so it's just plus 3. And the last one I had 4, took out 2, leaves me with 2. C squared, took out 1c, so I have 2c. Questions? Okay. Factor each using guess and check or Xbox. So these ones actually work well for guess and check. Okay, these ones actually work well for guess and check because the first term is 1. I have 1 d squared. I have 1 p squared. I have 1 z squared. So it's good to actually kind of do a guess and check on this one. It's not that hard. What I do is I look at the last number, factors of 6, that when I subtract them, I have 1 of each. When I subtract them, I get 5. So I have 2 factors of 6 that are 5 apart from each other. This is negative. This is negative. I'm going to have 1 of each. So I'm going to have a D minus and a D plus, just like some of you. Okay. 2 numbers that multiply to give me 6 that when I subtract them, I get 5. Factors of 6 are 1 and 6, 2 and 3. Which ones do I subtract to get 5? 6 and 1. Which one's negative and which one's positive? The 6 and the 1. Which one's negative? The 6 and the 1. The 6, because the larger factor is whatever this one is. So it's D minus 6, D plus 1. Okay, does that make sense? Okay, let's look at the next one. Factors of 42. Okay, and if I list my factors of 42, and when I teach foundations, I hammer factoring, and this is why. Today is why I hammer factoring. Factoring numeric numbers. Okay, 1, 42, 2, 21, 3, and 14. 4 doesn't, 5 doesn't, 6 and 7. Those are all the factor pairs of 42. Now, I have a minus, so I'm going to subtract them and get 1. Which pair of numbers, which factor pair, when I subtract one from the other, I get 1? 6 and 7. 6 times 7 is 42. 6 minus 7 is negative 1, or 7 minus 6 is positive 1. So this is my pair. Because the last term is negative, I subtract them. The last term is negative, I subtract. 6 minus 7 gives me 1 because I have 1p. So I have p plus, p minus. This one's positive. The middle term is positive, so I get my larger number is my positive one. My smaller number is my negative one. Okay, and this is just a guess and check. And I'm also going to show doing with one of these, doing the Xbox, but I like doing the guess and check with this one because if your first term is positive, it's essentially the same thing as the guess and check, or same thing as the Xbox. If I go to the last one, my last 2 numbers are positive. Okay, so I have plus 18, which means if this is plus, I'm going to add my 2 factors. Factors of 18, 1, 18, 2, 9, 3, and 6. Which one of those pairs add, because the last term is positive, add to give me 11? 2 and 9. So my factors are 2 and 9, because 2 plus 9 is 11. Now it's z, the last term is positive, the middle term is negative, so it's z minus 2, z minus 9. You have the same sign if your last term is positive. Okay? And this is what you're doing. Now, if you do the Xbox one on this, it works the same. Okay? Multiply and add. So I'm going to multiply to get negative 6 and add to get negative 5. Which 2 numbers multiply to give me negative 6 and add to give me negative 5? 1 and negative 6. 1 times negative 6 is negative 6. 1 plus negative 6 is 5. This is your Xbox thing. Middle term on the bottom. Last term if the first one's 1 on the top. Multiply to give me negative 6. Add to give me 5. Negative 6 and 1. Ooh, negative 6 and 1. Okay, that's the Xbox version. If it's 1 in front, it's the same thing without dealing with it. You're just kind of figuring it out in your head instead, which is nice if you can do that. If not, use the Xbox. I got no problem with that. As long as you're not playing on it, you're using it. Okay, sad attempt at the joke. Do those. Okay, so what I'm looking for is I'm looking for two numbers that multiply to give me 35, that add to give me -2. 7 and 5 multiply to give me 35. If I have -7, +5, so n minus 7, n plus 5. And just remember n plus 5, n minus 7, those are the same thing. Doesn't matter which set of stuff in the parentheses come first. Now, I can't switch the negative and positive. I have to switch the whole thing. There is a difference between these and n minus 5 and n plus 7. That'll give you a +2 instead of a -2. So you do have to pay attention to that. But I don't care which one of these come first. As long as the numbers here and the numbers here are the same, either pair can come first. It doesn't matter. I have some kids that get hung up on that. It doesn't matter. Okay. Next one, two numbers that multiply to give me 11 that add to give me -12. That's easy. If this is positive and the middle number is 1 more, it's 1 in that number. And 11's not factorable except for 1 and 11 anyways because it's prime. My only choices are 1 and 11. If 1 and 11 don't work somehow, it ain't going to happen. So I have y minus 1, y plus 11. Okay. The last one, two numbers that multiply to give me 48. Let's subtract, or when I add them, I get +2. So they're 2 apart. That would be 6 and 8. And it would be +8 and -6. What? You're right, both be negative. My bad. My bad. So on the last one, I have b +8, b -6. Okay, questions? Not too bad. All right, these ones, Xbox, guess and check is a pain in the butt. It really is. I can do it, but I've been doing this a really, really long time. The Xbox method is what you want to do for this. You'll notice over on the board, I wrote down how you fill it in. The top part of your X is A times C. First coefficient times the last number at the end. The bottom one is B, the number in the middle. So for this one, I have 2 times -3, -6, and then I have +1 in the bottom. 2 times -3 gives me -6. And then B, the middle one, I have 1x, so I have 1 in the bottom. I want two numbers that multiply to give me 6. Multiply to give me 6 that add to give me, well, excuse me, multiply to give me -6 that add to give me +1. 3 and -2. 3 times -2 is -6. 3 plus -2 is 1. Those are not my factors. Those are not what I put in parentheses because I have a 2 in front of the x squared. My next step is to divide both of these by 2. Reduce if possible. I cannot reduce the 3/2. I can reduce -2/2 to give me -1. So my factors, -1, I have x minus 1 from the -1. That's one of my factors. And then the 3/2. The denominator, I have 2x. My numerator, +3. Okay. So my denominator goes in front, my numerator goes in the back of that factor. 2x plus 3. Same thing on this one. 3 times 6 gives me 18, and then I have -11. two numbers that give me positive 18. When I multiply and add to give me negative 11. So factor choices are 1 and 18, 2 and 9, 3 and 6. 2 plus 9 gives me 11. I have negative 2, negative 9. Okay, negative 2 times negative 9 is positive 18. Negative 2 plus negative 9 is negative 11. I have something in front of the y squared. I have a 3, so I have to divide both of those by 3. Negative 2 over 3, negative 9 over 3. Reduce. Negative 2 over 3 cannot be reduced. Negative 9 over 3, yeah, that can be reduced to negative 3. These are what I make my factors from. So I have my numerator, 3y minus 2, because it's a negative. 3y minus 2 times y minus 3, because I don't have a fraction. Last one, 6 times 14 is 84. Negative 84 over negative 5. Right? 6 times 10 is 60 plus 4, 24. Yeah, 84. Two numbers that multiply give me 84, negative 84, and when I add them, I get 5. This is where factoring comes in handy. This is where knowing your multiplication comes in handy. Two numbers that multiply to give me 84. Well, I don't want two numbers that are too close, but I don't want two numbers, and I know it's not going to be like 1 and 84. It's not going to be 2 and 42, because they're not going to subtract anywhere close to each other. So I want numbers that look closer together. So I got to think, what times what gives me 84? 7 and 12. And if I take 12 minus 7, I get 5. Okay. So I have negative 12 and positive 7. 12 times 7 is 84. Negative 12 plus 7 is negative 5. Knowing your multiplication tables makes this easy. Once again, I'd like to go slap your third grade teachers. Okay? I think it's third grade when you cover most of this. Now, I have to divide by 6. Divide by 6. Divide by 6. This one reduces to negative 2. And this one doesn't reduce. So I get b minus 2 and 6b plus 7. Sometimes they're easy, sometimes they're not. Your turn. Do those three. Okay, here we go. So 5 times negative 4, negative 20, and I get negative 1. Two numbers that multiply to give me negative 20, subtract 1, negative 5, and positive 4. Divide them both by 5. And I get this is negative 1, so I have n minus 1. This one doesn't reduce, so it's 5n plus 4. Next one, 4 and 6 multiply to give me negative 24, and then I have 5. Two numbers multiply to give me 24 that are 5 apart, 8 and 3. Positive 8, negative 3. Divide them both by 4. That one doesn't reduce. This one becomes 2. So I have a plus 2, and then 4a minus 3. And the last one, I get 60 and negative 19. Two numbers that multiply to give me 60 that add to give me negative 19. They're both going to be negative. Negative 4 and negative 15. And then divide them both by 6. This one reduces to negative 2/3. This one reduces to negative 3/2. So my factors are 3 w minus 2 and 2w minus 3. Questions? Okay, I like this method. It works really good. I think it's the best way of organizing things. You got to know your factors. You got to know your factoring. Okay. This one says factor each trinomial using yes and check. Yes and no. You can set this one up using an Xbox or something like that. The idea behind these two problems is they are perfect squares. And the idea is I want to know, are they perfect squares? So look, is my first term a perfect square? Yeah, 64 is 8 squared and x. So I have 8x squared. And then my last term is 1 squared. 1 is a perfect square. If I multiply the two and double it, do I get my middle term? If I multiply 1 and 8x and double that, do I get 16x? I do, but this is a negative, so that means this needs to be a negative. So my factor actually is 8x minus 1 squared. It's a perfect square. Now, if you did the Xbox method and you worked it all out, you would get 8x minus 1 times 8x minus 1, which is 8x minus 1 squared. Either way, I would be okay with finding it either way. I really don't have a problem with you using the Xbox. If you don't recognize it as a perfect square, you will still get the same correct answer. But it's nice to be able to see a perfect square. So in this one, 81y squared, well, that's 9y squared. And 4 is 2 squared. If I multiply 9 times 2 and double that, do I get 36? Yeah, 9 times 2 is 18. Double that, I get 36. This is a perfect square. 9y plus 2 squared. Yeah. Okay. Any questions? So on the next one, I want you to try to do that. Look for it as a perfect square. If on the test you don't do it that way, but you use the Xbox to figure it out, I'm okay with that. But if you can recognize it as a perfect square, that's better. Okay, so once again, I want you to try to factor these, look at them as perfect squares. This is 5p. This is 3. Square root of 25p is 5p. Square root of 9 is 3. If I multiply the 2 and double it, do I get 30? Yes, but the middle term is negative, so it's negative and squared. 5p minus 3 squared. Just because the first and last term are perfect squares does not mean that the whole thing is. You've still got to be able to multiply them and double to get the middle term. If you multiply them and double and don't get the middle term, it's not a perfect square. It has to meet those criteria. First term and last term have to be perfect squares, and you have to be able to get the middle term by multiplying and doubling. Okay, so this one, 3h and 4. 3h times 4 is 12h. Double it, I get 24. This is a perfect square. If I didn't get 24, then it would not be a perfect square, and I'd have to just factor it normally. Okay? So like I said, if you use the Xbox on this on the test for factoring, I don't care. But it's nice to be able to recognize them as perfect squares. Okay? Okay, difference of two squares. This is another one. This is one where you have to recognize the pattern. If I have a perfect square minus a perfect square, x squared is a perfect square, 25 is a perfect square. Square root of x squared is x. Square root of 5, 25 is 5, so I have x minus 5, x plus 5. If your first and last terms, or if you have two terms, perfect square minus a perfect square, no middle term, that's how you factor it. Okay? 1 minus 4m, square root of 1 is 1. Square root of 4m squared is 2m. So I have 1 minus 2m, 1 plus 2m. 49a squared, this is a perfect square, 7a. 64b squared, 8b. 7a plus 8b, 7a minus 8b. Notice it doesn't matter which one's plus and which one's minus as long as you have one of each. Okay. Last one, perfect square, but what's wrong? It's not minus. It is not the difference of two squares with a minus. Okay? It's the sum of two squares. Doesn't factor the same way. Okay. It is, but you need complex numbers, and we're not doing those yet. Your turn. Do those four. Okay. So, d squared minus 9 squared, d plus 9, d minus 9, 4 squared minus 3x squared, 4 minus 3x, 4 plus 3x, 2c squared, 7 squared, 2c minus 7, 2c plus 7, 5y squared minus 1 squared. One of the biggest problems is kids forgetting that 1 is a perfect square. It's 1 squared. 5y plus 1, 5y minus 1. You know the pattern. This is probably one of the easiest ones to do it, but you have to know the pattern. You have to be able to recognize it. You recognize it, it's a piece of cake. If you don't, you struggle with it. Okay, last but not least, factor completely. When you see the directions that say factor completely, you must think to yourself, ooh, I probably have a greatest common factor that I should look for first. So the first one, 2m squared minus 32. Ooh, I have a greatest common factor of 2. I can pull out a 2 first. So I take and I pull out my 2. And then I have m squared minus 16. And then, ooh, can I factor the m squared minus 16? Perfect square minus a perfect square. M squared, 4 squared. So I have 2. Do not forget the common factor you pulled out. And then m plus 4, m minus 4. 4, not 5, 4. Can I factor those? No, I'm done. Okay, but factoring completely generally means you're going to have more than one factoring involved. And your first one you should always look for, and this is a good point to do anyways, always look for a common factor first. So I go to the next one, common factor. Ooh, I can pull out a 3. And then I'm left with 3n squared minus 5n minus 2. And oh, I got to set up an Xbox on this one. -6, -5. Two numbers multiply give me -6, and add to give me -5. -6 and 1. Divide them by the 3. This one becomes -2, so I have -2 and I have 1/3. So I have the 3. Don't forget the 3 you pulled out. Most common error is to forget the 3 that you pulled out, losing that common factor that's still part of the whole thing. And then I have n minus 2 for this, and this is 1/3, so that's 3n plus 1. That's my final answer, the common factor plus the next factoring. Same thing on the next one. Nothing numerically. 2, 1, and -15. Can't do anything of that. But I do have a y in every term. Pull out the y. And I'm left with 2y squared minus y minus 15. And then I see, can I factor that? -30, -1, Negative 6 times 5 gives me negative 30 when I multiply. When I add, I get negative 1. I have a 2 in the front, so I put that over 2. This one reduces to negative 3. This one doesn't reduce. Those are my two factors. So I have y, and then I have y minus 3 and 2y plus 5. Yeah, if you see the directions factor completely, that should be a giant sign that says you're going to have a common factor to pull out first. But you should always check for a common factor first anyways. But if you see factor completely, guaranteed, you'll have something like that. Do these. Factor completely, it's going to be 2 steps of factoring involved. Okay, in the interest of time, I want to do these because I still want to have you take at least one of the 2 quizzes today. So the first one, factor out of 3, you get c squared minus 4, square minus the square, 3 times c plus 2, c minus 2. The second one, pull out a w, and you get 3w squared plus 5w minus 2. Let's see, negative 6 and 5. So negative 3, negative 2, divide by 3. So I get negative 1. So I get w times w minus 1 and 3w minus 2. Is that right? No. Plus minus. Minus 6 plus. Wrong, 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 wrong. See what happens when you hurry? Negative 6, positive 5, negative 6, positive 1. Divide by 3. So I get negative 2/3. So I end up with w and 3w minus 2 and no. Yes, I am totally, see what happens when you get in a hurry? Let this be a lesson, you don't rush. Negative 1 and positive 6, divide by 3, and that's 2. So I get w plus 2, 3w minus 1. There we go. Last one, factor out of 2, and I get m squared plus 9m, sorry, 2m squared minus 9m minus 5. Used to be able to negative 10, 9, 10, negative 1, divide by 2. So I get 2 times m plus 5 and 2m minus 1. There we go. See what happens when you rush?